what I'm doing right now. Okay. Second slide just kind of tells you how to work it, so not super important. Let's take a look at the third slide. So drag the nets to the right to their matching three-dimensional solid. Now you guys have some experience with three-dimensional shapes from junior high math. So some of these you should be able to do pretty quickly, and then we'll narrow down the rest. For example, the cone is an obvious one. And we'll just drag that over. This one that kind of looks like a soccer ball, you can tell that each of these shapes are pentagons. So you just need to find the net that's only created by pentagons. So it is this one. That was too far. And then this next one is only created by square or triangles, sorry. But so is it this guy? Or is it this guy? Cooper? It's the one on the right. It's 4 triangles on the top and 4 triangles on the bottom, so we're looking for that net that has 8 triangles. Pyramid-looking thing only has 4 sides. So it is this one. And then number 5 is a square pyramid. Okay, notice there's some left. Those are the ones that go on the second page. So you could eliminate the ones that we've already done. Already did the cone. Already did that one. We did that one. Alright, number 6, it's a pyramid because it comes to a point, but the base is a hexagon. So it's this sun-looking shape. Has a hexagon and then the triangles coming off of it. 7 is a cube. 8's a rectangular prism. And 9 is a triangular prism. Those are the 4 nets that go with those shapes. And we'll go to the next slide. Alright, and see if you can get those 4 going. Okay, I hope you did that for the cylinder. 1, 2, 3, 4, 5. Hexagonal prism is this guy. Has a hexagon top and a hexagon bottom. And then rectangles for sides. Number 12. Excuse me. All triangles. We already did the one that already had 8 triangles, so it must be this one with a whole bunch of triangles. And 13 has a pentagon on the bottom. So it is this one. Notice the different, these 2 are both prisms. There's just a different way of unfolding them. These 2 here on the bottom, if you can see it. One, they did all the triangles together, and one, they kind of fanned all the triangles out. Okay. We're going to identify the shapes by their names. Thank you. Remember, prisms come to one single, no, sorry, I said that wrong. Pyramids come to one single point. Prisms are like a box, meaning they have a flat top and a flat bottom. And then these other shapes, like the soccer ball looking one, are called tetrahedrons. They're made up of, no, they're called polyhedrons because they're made up of polygons. So easy one, cylinder. This one is a pyramid, and its name is determined by its base. Cone, you know. The fourth one is another pyramid. It looks a little funky because it's triangle. It has a triangle base, which is not an option. So a triangular pyramid is what I would have called this. But apparently it has a special name made up of 4 triangles. I believe it's the tetrahedron. But, just to be sure. Yep. Tetrahedron is made up of 4 triangle faces. There we go. These 3 are all prisms because they'll have flat bottom with flat top. The weirdest side determines its name. So the orange and green one is a hexagon prism. This one is a rectangular prism, which is not an option. Okay, that's not an option either. Oh, so cube we can use, also known as a square prism. This is a rectangular prism. How come it doesn't have a name? Let's skip that and move on. These are the ones I know. This is a, right here, rectangular pyramid. That's not an option either. Okay, rectangular pyramid, I got that one. Triangle prism. Well, maybe this is supposed to be a square. Square pyramid. Can I go a little higher for you? Okay, octahedron is something with 8 sides. I know that. So that goes here. Tetrahedron was 4 triangles. Octahedron is 8 triangles. So dodecahedron, how many triangles do you think that one has? More? 12. Remember, dodecagon was 12-sided. So dodecahedron is a 12-sided 3-dimensional shape. And I think the soccer ball is the icosahedron. And whoever wrote this must be from Europe, because they called the rectangular prism a cuboid. We call them rectangular prisms. I'll look up icosahedron. How many sides does that have? Icosahedron has 20 sides. A polyhedron with 20 faces. So it doesn't have to be triangles because these are pentagons, but there are 20 of them. Any questions on that sheet? Wonderful. Okay. So now we're going to fill in some missing information. Hurry. Alright, I moved it down and now I can't move it back up. Alright. They gave us a nice easy one to start with, a cone. Faces, edges, and vertices. Faces are easiest to think of when it's unfolded. How many surfaces are there on a cone when it's unfolded? Alyssa? It's 2. This is what the net looked like right here. It's only 2. Edges are where the 2 faces meet. There is only 1 edge on a cone. Let me make this bigger. And then there are actually 0 vertices on a cone. The point at the top is called an apex, but it's not a vertex because it's not a corner where multiple faces meet. That's just where the one face kind of wraps around itself. So it's an apex, not a vertex. Okay, soccer ball. Do you remember? It was the icosahedron. I'm sure I spelled that wrong. But we looked it up and it had 20 faces. Okay, if we're going to do all these funky shapes that are really hard to visualize, there's a formula called Euler's formula. I wasn't going to go over this, but I think it would be beneficial. Euler's or Euler's, I don't know how to say his name. I don't want a video. Here we go. Faces, edges, three shapes. Go away. Here's Euler's formula right here. Real little. Yikes! I don't need help. Go away. Faces plus vertices equals 2 plus edges. That's the formula. Oh, look here. Well, that's not. Oh, they gave us icosahedron. 20 faces. That we got. 12 vertices. 30 edges. So we would need 2 of the pieces of information to fill this in. So I guess Euler's formula is not super helpful. But we're going to cheat and take this information. So 12 vertices, 30 edges. Oh, wait, I don't want you. Close. 30 edges, 12 vertices. And you can't just multiply the number of faces by 5 because some of those edges all get shared. So it's a little hard for those big ones. And we might skip some bigger ones. Good. To zoom in, use the magnifying glass icon up by the paint roller. Do you see it? In your gray bar? No. Okay. And then make sure you unclick the magnifying glass and click on the arrow, otherwise you'll just keep zooming in. Alright. 3. This one we can do reasonably. This is a tetrahedron. No, not a tetrahedron. There's 8 shapes. An octahedron. 8 faces. You can count the edges here because it's actually feasible. There's 4 on the top, there's 4 on the bottom, and there's 4 around the sides. 12. The number of vertices, there's the top corner, the bottom corner, and then there's 4 corners around the middle. So there are 6 vertices in an octahedron. Oh, come on. It's all the way over there. 4 is a tetrahedron. Tetrahedron. Yep. Yep, that's spelled wrong. Four faces, 3 triangles along the top and 1 on the bottom. 1, 2, 3, 4, 5, 6. 6 edges, 3 along the bottom, 3 going up to the top, and 4 vertices. This one is it doesn't look like a square to me. It looks like a rectangle. Rectangular pyramid. And if it happens to be a square, that's fine, because a square is a rectangle. How many faces here? Oh.
4.
Bottom? 5. How many edges? 8. 4 going up to the point, 4 around the base. And vertices? 5. Good. Total coincidence that bases and the vertices are the same. Oh, there's another one. Alright, so this one's also a pyramid, and the name is based on its base. That's a hexagon. So it's a hexagonal. Hexagonal. That's an O. Hexagon, A-L. Hexagonal. Pyramid. Take 2 seconds, fill in the faces, edges, and vertices. Oh. In this section or in a different section? I need to zoom out. It. Whoa, hello. Not this one? This one. Icosahedron, dodecahedron. Very likely. Ah, yes. So the dodecahedron looks like it's the one with the pentagons. And icosahedron. Looks like, I think you're right, Ella. Dodecahedron has 12 sides. 2, 3, and I could see 6 of them, so that means I can assume that there's 6 on the other side. Good. Can I see 10 here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. I can see 10 there, so there must be 10 on the back side. Good catch. Icosahedron and dodecahedron shouldn't have been switched. Okay, so then for our hexagonal pyramid, how many faces? No. Cool. Oh, do I need to change the name? Did I do that one wrong too? Yep. Dodec. So it's not 20 sides. Whoops. 12 sides. Oh, how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still got 30 edges for a dodecahedron. 20 vertices, 30 edges, 12 faces. 30 edges, 20 vertices. Interesting, it's the same number of edges. Huh. Okay, I think we've got them all fixed now. Alright, hexagonal pyramid has 7 faces. 6 triangles going up to the top, and then the hexagon on the bottom. It has 12 edges. 6 edges going up to the top, 6 around the bottom, and 7 vertices. Sorry. Okay. Next and last page. This didn't take nearly as long as I thought it would. You can call this either a square prism or a cube. Square prism or a cube. Six faces, 12 edges, and 8 vertices. Okay. This person who made this assignment called this a cuboid. Normal people call this rectangular prism. It's not a square prism because not all the sides are square. It's a rectangular prism because the bases are rectangles. Faces, edges, and vertices of a rectangular prism are exactly the same as in a square prism because it's just stretched longer. So it's still 6 faces, 12 edges, and 8 vertices. Number 9, we have the container of Toblerone. Have you ever seen those long chocolate bars that are shaped like triangles? Triangular. Is it a pyramid or a prism? Prism. It doesn't come to a point. It would stand up like a box.
Start to meet.
Oh, that was different. 5 faces. 9 edges and 6 vertices. Okay. Sorry, I gotta get finished for the meat. 5, 9, and 6. Okay, cylinder. 3 faces, 2 edges, 0 vertices. Like the cone, messes things up. "11 is a hexagonal prism. It has 8 faces, 6, and 18 edges, and 12 vertices. And this one is that icosa one that I messed up before, right? Icosahedron. So it was 20 faces, 30 edges, 3, 6, 7, 8, 9, 10, 11, and 12 vertices. And last one. Pentagonal pyramid. 1, 2, 3, 4, 5, 6 faces. 5, 6 edges. No, I was cutting the wrong thing. 6 vertices. 10 edges. Okay. So I want you to link this into your SV notes, because I forgot to change that to AV. I'm going to get this posted for everybody at home. And I'll see you guys in the meet.